everyone. My name's Chris Colby. I'm a K-12 Principal Architect here at CPL. I've had the fortunate ability of working in the K-12 practice area on schools nationally for close to a little over 20 years now. Today, I'm joined with my colleague, Tom Phoenix, who is a mechanical engineer. And before we dive into this topic of ventilation and systems in schools, Tom, why don't you give us a little bit of your background and your 60-second elevator pitch about who you are?
Well, sure. Thank you, Chris. I'm Tom Phoenix. Again, I'm a principal engineer with CPL. And I'm also very active in ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers. I am a past society president of ASHRAE. I'm currently involved with them as the co-chair of the Task Force for Building Decarbonization. I'm also the chair of their Advanced Energy Design Guide Steering Committee. ASHRAE has also been very active with an epidemic task force to look at the COVID issues. And so I have been very active with them for a long time.
Yeah. So for those that don't exactly know what ASHRAE is, could you give a quick snippet of what ASHRAE does for the engineering community in buildings?
Well, again, ASHRAE is an acronym, although it is now the legal name of the organization. The American Society of Heating, Refrigerating, and Air Conditioning Engineers. They're basically a standards writing organization. They are the accepted standards for a lot of issues, not only in the heating and air conditioning business, but also the general built environment. They write the ASHRAE 90.1 is the flagship energy code for most of the United States. Most of the municipalities and in the U.S. use 90.1 as their energy code. And so basically they're a standards writing organization. They also do a lot of research and a lot of information exchange, training sessions and seminars and things like that. So they're basically the recognized leader in the HVAC world.
Perfect. So I want to dive in here. I've had the opportunity and fortunate circumstance of working with you and the other engineers in the firm here, specifically when it comes to ventilation and heating and cooling systems and things related to COVID. And you mentioned that ASHRAE's kind of set some of those standards as it relates to how to deal with, COVID and other pathogens in buildings. And there's a lot of misinformation out there. I know you and I have talked at length over the past really 18 months, and you've done a lot with our other architects and engineers in the firm to help demystify some of the, really kind of snake oil things that are going on in the marketplace. So really what we want to talk about today is let's pull back the curtain and get to the truth here. And ASHRAE and yourself have done a lot. You've done some white papers on this. ASHRAE has done a lot of research on, what works, what doesn't work, and really just want to break this down on a couple simple things. There's 4 things I really want to talk about here. Ventilation, filtration, decontamination, and humidity control. And we're going to make them super simple for everybody. So let's start with ventilation, because that's really the most important. And maybe we can talk about why that's the most important and what, there's 2 avenues here. It could be a new building. It could be a retrofit. So I think we need to, talk about those individually. But let's start with ventilation. Why is ventilation so important?
Well, so let me start the answer by telling you all of the 4 things that you identified, and a lot of the emphasis of our engineering, design, and consulting practice are based on the premise that the COVID virus is basically an airborne virus, and so all of the 4 parameters that you mentioned have to do with HVAC systems because they blow air around. They basically have the potential of circulating the virus from one part of a building to another through airborne, through the air, through the HVAC system. So let's attack those things. You asked about ventilation. Ventilation is an easy thing to do, potentially, because it's a known fact that if you can dilute the air in a space with more outside air, then the potential for continuing to recirculate pathogens goes down. And so basically the whole idea of increased ventilation means that you are recirculating less and less of the pathogen each time. You are introducing more outside air and basically diluting the virus. That's the whole premise behind ventilation. In HVAC systems, you can do that by adding more outside air through air handling systems. You can also do it by just opening the windows.
Yeah, great. Perfect example.
Yeah, and natural ventilation is becoming more and more of something that people are looking at these days, just to increase the ventilation in their space.
Sure. So simple example you just gave, open the window, more fresh air into the space, dilutes the potential for spreading pathogens. What about the mechanical systems? Many schools operate off unit ventilators. Some of them have central systems, some of them don't, depending on the age of the building. If it's a new build, it's simple. Somebody, a district would contact you. We design the system to incorporate as much outside air into the system as possible. But when it's an existing building, how do you go about that?
Well, it may be simple, it may not. How old is the building? If the building is old enough to have operable windows, then we can go right back to the simple solution that you just mentioned. If it doesn't have operable windows, we may need to look at retrofitting the systems in the building. We actually have gone through a couple instances where the entire system in the building is going to be replaced just because the older system did not provide the potential for additional ventilation. And so yes, it's a little harder in an existing building, but not necessarily. It really depends. You have to look at it on a building by building basis.
Yeah. So every building is unique.
Every building is unique, and every building should be assessed to see what's the best solution, what's the easiest way to get more ventilation in the building.
Sure. So moving on to the next topic, ventilation is important. I'm sure we might come back to this as we continue to talk, but let's say ventilation isn't maybe top of mind. And this is where I think some of the snake oil sales come into place, talking about filtration, right? You have many schools that either have old or outdated systems. They need a solution right now. It's very difficult to get funding in place immediately to just go and gut a whole building and start over and get the right system in quickly. And so usually you're looking at a filtration sort of setup to deal with handling, a COVID type situation or other pathogen situation. What is the right way to filter air in a building?
So almost all air handling systems in commercial buildings, including school buildings, have filters in them. You have filters in your air conditioning system at your house.
Right.
And ASHRAE some years ago developed a rating system for filters that gives a numerical rating to a filter based on how small of a particle that filter would capture. As it turns out, the coronavirus is very small. Less than a 0.3 microns, basically, if you are interested in the numbers, but
super small.
A MERV 13 filter that in the MERV rating, in ASHRAE's MERV rating, A MERV 13 filter is the first range of filters that begins to capture bacteria and viruses. And
the higher the number, the better
the higher the number. Yes, I'm sorry. The higher the number, the better the capture. And so you can get up to a MERV 16 filter, and then there are HEPA filters, high efficiency particle filters, that can capture pretty much everything. But in the ASHRAE rating system, and what we would recommend to schools is that you look at least changing your filters to a MERV 13 filter. Most filters these days, the standard 2-inch filter that's in a commercial air handling system is really not MERV 13. MERV 8 is pretty common. So upgrading your filtration system to MERV 13 is a really good first step. Now, there are some consequences to that, MERV 13 filters, because they are tighter, basically, and capture smaller particles. It takes a little more fan energy to push the air through the filter. So there may be some energy consequences to that. And the other issue that we have begun to run into a lot is that existing air handling units, the filtration space maybe isn't designed to hold a filter that would be as wide as what you would need for a MERV 13 filter. Just pulling out a MERV 8 and swapping a MERV 13 is not always just a one-for-one swap. And so, again, every system is unique. Every system needs to be looked at just to make sure that we can give you the proper solution for your problem.
Yeah. So is it likely if I have a school where the system's 10, 15, 20 plus years old, that system, the fan and the filter space, you just can't throw the MERV 13 in and hope it's going to work if it even fits, right? It's more of one, does it fit? And two, can that fan push the air through it?
Right, exactly. You can swap the filters, but you may see without some adjustment in air balance, maybe even some adjustment in increasing horsepower on the fan. Without those adjustments, you may see a decrease in airflow, which would have an effect on your space conditions. Right. And so we don't want to give up one thing just to accomplish something else.
Sure.
And so that's why every system needs to be looked at and to find the right balance and the right solution.
Yeah, and I bring this MERV conversation. I think everybody became familiar with the term MERV 13 over COVID through the pandemic because it was recommended to swap your filters out, but it wasn't that simple. So I think it's good to bring up here, there are consequences to trying to do that if it works at all with your existing system.
Right.
What about third kind of party solutions where you drop a portable filtration unit in the classroom?
Well, some of those systems actually work, and that is kind of a potential. I don't know that I would call it a long-term solution.
More of a Band-Aid fix.
Yeah, but if you needed an immediate way to try to mitigate the transmission of the COVID pathogens. Portable filtration systems work. There some work better than others. I will tell you, there's some products out there, and that work really, really well. Some that don't work so well, and you'll see them in all kinds of shapes and sizes and different technologies and all of that. But it is possible to. If you can't do the things that you need to do to increase the filtration capacity of your main air handling systems, it is possible to add standalone filtration units directly into the space. Put them over in the corner of the space, and they will begin to recirculate the air through that unit and capture the viruses.
Really important, though, to make sure you have an engineer review it to make sure the system is not some sort of cheap off the shelf thing that isn't really filtering the air. So there is a lot of stuff on the market that looks and is said to do filtration, but doesn't necessarily.
And those units also have to be sized properly.
That's right.
Even though you are adding to your main air handling system, those units still have to be sized properly. You can't just put a little bitty unit in a great big room, for example, and hope it's going to work.
Yeah.
You know, they have to be sized properly. They have to be selected so to be suitable for the space in which they're going to be installed.
Great. So let's move on to decontamination. And let's try to break down before we go into decontamination, what does decontamination mean?
So decontamination is basically killing the virus. Disinfection is another word that's being used. There are some technologies there that will, that will take care of basically killing the virus somehow. Surface cleaning areas, that's easy. You know, there are lots of products out there that you can use to clean the surfaces in your space, and that will kill bacteria and viruses of all shapes and sizes. Doing that in an airborne, with an airborne pathogen is a little harder. And there are a number of products out there that work, and there are a number of different kinds of solutions that are being sold basically in the market these days and being promoted in the market. I'll hit just a few of the more common. UV light is probably the most common. UV light in certain wavelengths has been shown to kill the coronavirus. And so you will see a lot of products out there these days that talk about UV. The range in which a UV light becomes effective in killing pathogens is what's known as UVC. And that's the wavelength where the pathogens will not survive. However, in order to kill a pathogen with UV light, the effect is not immediate and instantaneous. The pathogens have to be exposed to this UV light depending on how intense the light is and how far away they are from the light. But basically, they have to be exposed for a period of time. Typically, if you're 6 feet away, you need exposure for several minutes. 2 minutes is kind of the number you hear a lot. And so you'll see a lot of products that just sort of hang in a piece of ductwork, a piece of air ductwork. Those are not necessarily all that effective because
the air's passing quickly.
The air's flying by too quickly, and so the UV light doesn't have enough time to kill the pathogens that are there. UV light is very effective in bathing the cooling coils in an air handling unit or the filter banks in an air handling unit. Those are very effective because those two spots in the air system are where the pathogens can get trapped, and so there's a chance there that they can be killed because they will be exposed for the right period of time. There are a couple other technologies out there. There's one called bipolar ionization. It got some promotion, and then there's been some studies that showed maybe it's not so great. It really, again, you need to look at it. You need to be sure that you are looking at the right material. And then hydrogen peroxide, liquid hydrogen peroxide being sprayed and introduced into the space has been shown to be somewhat effective. There are a number of products out there that promote that. It's unfortunate. You mentioned snake oil in your opening remark. It's unfortunate that this is the area with all these disinfecting machines where a lot of snake oil is coming around.
Sure.
But again, there are some really good products out there that can do what they claim to do. Again, you should enlist the help of someone who understands those products and knows how to apply them properly.
Yeah, I think decontamination is a nice thing to have, but a difficult thing to have compared to some of the other things we just talked about. Is that a fair statement?
Well, it's certainly a bit of a capital expense.
Sure.
I mean, they're not just going to give away those various units, the UV light units and the other decontamination units. They're not free. So, and that's where a lot of the sales folks jump all over this. Yes, it's a little more expensive, and it does take some planning to do. If you're going to retrofit your air handling unit and install UV lights, you have to make sure it's installed properly in order for it to work. There are some safety considerations with UV light. Exposure to UV light is dangerous to humans.
Sure.
And so you have to plan to retrofit your system properly.
Has to be well thought out.
Exactly.
And I think some of the other things, the UV light, you mentioned contact time, even the hydrogen peroxide being put into the air. This kind of goes back to the filtration units that are being sold third party. Is it sized properly? Is it spraying in the right areas? Is the contact time appropriate for the occupancy of the space? These are all things that need to be. You just can't throw a UV light in your ductwork or a hydrogen peroxide, system on the wall and hope that it's going to cover the space.
Right. Exactly. And there are lots of. You mentioned wall-mounted units. I've seen just recently about 5 or 6 different types of wall-mounted units that use all of the technology that we just talked about: UV lights and bipolar ionization and hydrogen peroxide. They claim that you hang this wall in you hang this unit on your wall in your space and you solve your problem. And it doesn't really work like that. It really needs some evaluation and making sure that you're doing the right thing.
And so almost a false sense of security.
Exactly.
Yeah. So decontamination's great, but a lot of planning has to go into it, designed properly in order for it to be effective.
Right.
All right, so last one here. So this is the fourth one that I wanted to talk about. This one I find very interesting, humidity control, because this one tends to get overlooked quite often, but has such a, I want you to bring up the 40 to 60% thing if you can.
Yeah, and this one actually potentially is the easiest thing for you to do in your system, because you should already have controls on your system. That you certainly have a thermostat that controls the temperature in your space, and you probably already have some kind of control in your system to at least look at dehumidification. What has happened is that in technical research, it has been shown that in relative humidities between 40 and 60%, the airborne transmission of pathogens basically stops. If you look at a graph, and the white paper you mentioned, there is a graph in that white paper that shows this. When the humidities are pretty low, the viruses, there's nothing to prevent them from flying all around. And pathogen transmission in low humidities is pretty high. Between 40 and 60%, it almost stops. In all the research and experiments that they have done, pathogen transmission doesn't go from one place to another almost at all in those ranges of humidities. And so if you could control your space environment to maintain, between 40 and 60% humidity in the space, you have already done an enormous amount to control the pathogen transmission through airborne transmission. So it's kind of easy. It as you mentioned a minute ago, it really is an amazing piece of research. It's very surprising, that something that simple, but the research has shown it to be that way, and that's easy to do.
Yeah. Yeah. Compared to some of the other things we talked about,
Yeah.
not a huge, everything costs money, obviously, but not a huge expense. And most systems already have some sort of humidity control built into them if they're not too old.
Right.
So this is a low hanging fruit almost.
Exactly. Yep.
So if you had to rank these, I always say fresh air is the best, but you're the expert here. So is it humidity control would be the first thing you would start with?
Well, I don't know that to rank which one of these four is the best over one of the others. I don't know that you could pick one.
Sure.
Again, every situation is different. Every system is different. You need to have someone look at what the right way to do this. As we just mentioned a second ago, temperature and humidity control might be relatively easy, and that has shown, again, to kind of stop the virus transmission, but not completely eliminate it.
Sure.
Filtration is really important, and ventilation is really important. Now, ventilation, if you don't have operable windows in your space, ventilation is certainly diluting the air in the space is important. You'll see lots of written recommendations that says, please convert your air handling system to a 100% outside air. But that's not easy to do.
I was going to ask you about that.
First of all, if you have an existing system, your air ducts and your air handling systems are probably not sized to do that. And if you do that, there is a tremendous energy penalty that you're getting ready to pay, because now you have to condition 100% outside air. If you live in the South, that means you've got hot and humid air in the summertime that you have to condition to room conditions. If you live in the North in the wintertime, you have to heat up really cold outside air all the time. So there are lots of energy penalties there. So ventilation, diluting of the air with outside air is very effective for controlling the virus, but it's maybe not the easiest thing to do.
Probably one of the more difficult or more costly things to do, exactly. I guess would be the right way to look about it. So while we wrap up here, there's a lot of different funding mechanisms that have been introduced by Congress, ESSER funding and all these other things that kind of chase, or at least are allowed to be applied towards some of these solutions, including the snake oil salesman stuff. So, what advice would you give to somebody, a school system that's looking to, hey, have this old building, we know some of our systems aren't where they need to be. Do we do the Band-Aid fix? Do we back off and try and do this the right way? Like, what would you recommend? Should they just throw money at, the snake oil salesman that walks into the district, or should they maybe take a step back and say, all right, what's the right way to go about this?
Well, there's probably not one answer to that question. It really depends on your situation. As you mentioned, we are aware of some public funding that may be available to help people through some of this. But the long-term solution to us is kind of the best. The pathogen issue is not going away anytime soon. Unfortunately, the COVID thing, now we're into the Delta variant. Who knows what comes next? And once we conquer COVID, what's the next pathogen going to be?
Sure.
Retrofitting systems or installing systems that will take care of this problem in terms of trying to mitigate airborne transmission is certainly the best approach. And if you can find funding to do that, that's fine. I will tell you that we have a couple personal real life examples of a couple of our clients that said, we want to add UV light to our systems. And we looked at it and said, I don't know that that's very effective. But the salesman outsold us, and they went ahead and put the lights in there. I'm not sure they're doing a whole lot of good, but they spent money on it. So you don't want to throw good money after bad.
Yeah.
And each individual, we've said this a number of times, but it really bears repeating. Each system and each scenario really is unique, and it requires some analysis, and you need to find what is the right solution, what's the best solution for your particular situation.
Yeah. In some ways, isn't this a really indoor air quality conversation? COVID and some of these, the pandemic has put a spotlight on, the pathogen conversation. But
Yes.
I mean, really, we're talking about indoor air quality. If you wanted to break this down very, very simply, how clean is your indoor air inside of your school based on these sort of things that we just talked about?
Absolutely. No, that's a great way to put it. The transmission of pathogens, whether it's COVID or whatever, has now put a spotlight on the whole world of indoor air quality. Some of the titles are changing. What used to be IAQ is now IEQ, indoor environment quality. But you are absolutely correct. This whole situation has put a spotlight on that, and basically what we are trying to do is make sure that the environment in which we live and work is comfortable and safe, and that's what this is all about.
Great. Well, thank you, Tom. I really appreciate you demystifying some of these things for our guests. And I know you've been doing this with me for 18 months now, and some of the other people on our team. I think if you're okay with it and we can find a way to do it, I'd love to put a link to your white paper wherever we're going to be posting this, because if anybody wants to do a deeper dive, I think they want to, maybe some light reading in the evening, that would be a great place to go. But
That's great.
Thank you again. And
yeah.
Of course, anybody can check out, there's more information on our website about all of this and the information that you have specific to these systems.
Yep, absolutely.
All right.
Thank you for interviewing me. This is great.
Yeah. Thanks for joining us. Take care.